Okay, so we're looking at the second year Stats and Mechanics textbook. We're doing exercise 80, which is on integrating vectors. Okay, so I'm given the acceleration as a function of time. And the first thing I'm asked about is the velocity. So before we worry about the finer details, let's just get cracking. So, and this is an exam question, so that's really handy. It sort of shows you the level we're trying to get to. It's not a problem-solving one, so that means it should be sort of just relatively straightforward as long as we know, the overall method. So as long as I know that the velocity is going to be the integral of acceleration, and they don't refer to that, so that's definitely something I'm expected to just know. So we're going to integrate that with respect to t. Okay, so 4t is going to integrate to 4t squared over 2. 3 is going to integrate to 3t. And for this one, I'm going to do the constant as a separate vector on the end. I've done some of the earlier questions slightly differently. Textbook does it as a separate vector on the end. Whichever way makes most sense to you is fine. So if you prefer to put your plus c with your I vector and then use a different letter with your j vector, that's absolutely fine. So 6t squared is going to integrate to 6t cubed over 3. So it's going to be 2t cubed. And then there will be a constant, or there could be a constant, so I need to put plus d. Okay, and then it tells me that t is 0, the particle is at rest. So when t is 0, v is 0. So that does, if you can already spot that tells you that vector d will be 0, that is fine, but you do need to just show that. So you can't just not put any constant of integration. Okay, but let's just sub it in. So v is 0 when t is 0. So if t is 0, that's 0 and that's 0. So put 0i, I could just put nothing. If t is 0, then 2t cubed is 0. Okay, so basically d is 0. Okay, but you do need to just show that you have considered that. Okay, so that's my full velocity vector. Okay, and yep, so quite like I said, not a problem solving this one, so it's a bit easier than the previous question, I think. So when t is a half, we're just going to get the velocity, and it doesn't ask for speed, so I don't need to do the magnitude of it. So 2 times the half squared minus 3 times a half. I get, I'll double check my answers in a second, but I get that's 13 over 2i, and then a half cubed times 2, and I'm getting is a quarter j. And let's put some units, and let's just double check my calculator work. Oh no, okay, so something has gone wrong with I. So what have I done wrong? With I, is it my integrator? I think the integrator was fine. Okay, so it's just me typing into the calculator. Let's try that again. So 0.5. So I'm just hoping I can spot what I've done wrong there. So let's try it again. So 0.5 squared times 2 minus 3 times 0.5. Yeah, it's just me being daft, typing into the calculator wrong. So that does just come out as minus I minus a quarter j. Okay, it's more like it. Right. And then the position vector of p when t is 6. Again, they're not playing around here. There's no sort of tricks to this. It's just a straightforward. You need to know that position, it's going to be the integral. Also, when we're doing that, is the integral of your velocity vector, which is this vector here. Okay, so integral of 2t squared minus 3t I minus 2t cubed j. Okay, so again, I'm going to do this where I just integrate I and j and then have a constant as a separate vector on the end. So 2t squared is going to integrate to 2t cubed over 3. 3t is going to integrate to 3t squared over 2. 2t cubed is going to integrate to 2t to the power of 4 all over 4. So that will simplify to t to the power of 4 over 2, I think. Hope anyway. And then there'll be a constant, and in fact, I've already used d. So let's use a different constant. Okay, so they tell me, so look at the position vector now, they tell me that the initial position is 4i minus 6j. So this time round, my constant is not going to be 0. So when t is 0, r is 4i minus 6j. So basically, 4i minus 6j is, so if t is 0, then that is all 0. If t is 0, that is all 0. So that constant is 4i minus 6j. Yeah, that constant there. So my full position vector is going to be 2t cubed over 3 minus 3t squared over 2, and then plus 4. I'm going to collect all my I and j terms together, and then I'm going to be, I just need to be very careful with this minus. So in fact, I'm going to put plus minus t to the 4 over 2, and then I've got that minus 6j as well. Okay, I could have had a minus there, and then they would both have been plus. Okay, as long as you're absolutely sure you've dealt with the minus correctly. So find the position when t is 6. So let's just check that. So when t is 6, okay, what have I got? I've got 6 cubed times 2 over 3 minus 3 times 6 squared all over 2 plus 4. So I'm getting that to be 94i. So I'm just subbing 6 into this. Okay, so then I've got minus 6 to the power of 4 all over 2 minus 6. And I'm getting that to be minus 654j. Let's just check those. Which we're happy, yep, 94 minus 654, and should always include the units.